After decades of secrecy, the US government has shared a new report revealing what it knows and doesn't know about unidentified flying objects, or UFOs. But renowned astrophysicist Adam Frank says there's little evidence to show a correlation between UFO sightings and extraterrestrial life and intelligence. This May, Frank wrote a guest essay in the New York Times titled, "I'm a physicist who searches for aliens. UFOs don't impress me." Hello, everyone. I'm Chitra Ragavan, and this is Techtopia. Joining me now to talk about his search for life on other planets is Adam Frank. He's a professor of physics and astronomy at the University of Rochester and a leading expert on the final stages of evolution for stars like the Sun. Last June, Frank won a NASA grant to fund his study of so-called technosignatures. These technosignatures are clues of past or present technology used on other planets. This is the first NASA non-radio technosignature grant ever awarded and represents an exciting new phase in the search for extraterrestrial intelligence. A self-described evangelist of science, Frank is a frequent commentator on NPR. He also is the co-founder of NPR's blog 13.8 Cosmos and Culture. His most recent book is called Light of the Stars, Alien Worlds, and the Fate of the Earth. Adam, welcome to Techtopia.
Oh, thank you so much for having me.
So in your recent New York Times guest essay, you write, there are excellent reasons to search for extraterrestrial life, but there are equally excellent reasons not to conclude that we have found evidence of it with UFO sightings. So what's wrong with our current thinking in linking UFOs with extraterrestrial life?
Well, the biggest problem is that, with a UFO, by definition, is something that's unidentified. And then the question is, how do you go from something you don't know what it is, you don't understand what it is, to then making conclusions about what it is? And the point I was making in that article was, as interesting as these things are, and they are interesting, there's just nothing close to the kind of data a scientist would need to be able to reliably and verifiably conclude that these were, this extraordinary conclusion, these were actually, alien spacecraft that had ventured across the vast distances between the stars and were showing up here to investigate us, and they want to be secret, but they're not really very competent at remaining secret, right? So there's just, that link is just completely unwarranted.
Yes, and of course you've got all the science fiction where all of these aliens are wearing human clothes and they speak in English, and they seem to like Detroit a lot for some reason. So I guess that...
Right. Well, as I always like to say, if it sounds like a science fiction story, it probably is. And the problem with the way people link these sightings with, the conclusion that it's something from another world, which, to even find microbial life on another planet would be the most extraordinary discovery in the entire history of science. So you're going to need pretty strong evidence for that. But to make this even larger leap that we're being visited by advanced creatures, it almost always ends up sounding like a science fiction story. Because really, if they're visiting, why don't they just land on the White House lawn and be like, yo, we're here, what's up?
So the U.S. government recently released videos taken by Navy and Air Force pilots, and you've seen them as well, of the so-called unidentified aerial phenomena, the new term for UFOs. And, these pilots, and we actually had one of the pilots, Alex Dietrich, on our podcast, they've given highly credible accounts of what they have repeatedly seen. So what do you make of their accounts and observations, and your reasoning as to why they don't automatically assume that these are alien species checking us out is correct?
Well, the problem with, first of all, always with personal testimony is that there's not a whole lot you can do with it as a scientist, especially to try and ascertain whether or not what they're seeing has anything to do with aliens, right? What do I really need if I want to say, I've detected something that must be alien? I would need to know that it was, I would need detailed data from lots of different angles at lots of different wavelengths with lots of different sensors to tell me that it was behaving in ways that absolutely was impossible, that violated the laws of physics. For example, that it was accelerating at rates so high that no known metal could handle it. It would just, the metal would just, deform. And so somebody telling me a story that they saw something that moved really fast, that's just, they can't tell me how close it was, how far away it is. They can't really tell me what the speed was, right? All they can do is just sort of say it was really fast. And so there's just, there's just nothing there to really sort of grab hold of to make the kind of a conclusion that you want. I mean, if your friend tells you, your friend you really trust says, I saw a ghost, right? And you don't believe in ghosts. Okay, you believe your friend saw something, but what can you do with that story? And so, I think these pilots are definitely seeing something. That's why I'm saying there is something interesting here. It should be studied. It's the link to extraterrestrials that is really too much, right? There's more plausible explanations, like it's a peer state adversary deploying, maybe even simple technologies against us to soak up our electronic signals to see what we're capable of, than aliens, right? That's a big leap.
So in this report, what kinds of things would actually interest you as a scientist and as an astrophysicist and someone who's searching for life on other planets?
Well, the report would have to have, this is what it would really have to have, because this is the same, what I'm going to describe for you are the same kinds of procedures that we would go through using telescopes to find evidence of alien civilizations or alien life at all. We would need to know, we'd need electronic signals, or detectors, radar, infrared, ultraviolet. We'd have to have detailed data from those devices. We'd have to know how those devices worked. We'd have to be able to characterize those devices so we could tell whether or not the signal that we were getting was somehow a shadow, an image, an imperfection. When we build telescopes, there's a huge amount of work that goes into just characterizing how the telescope responds to light. So unless there's multiple different kinds of detectors and characterizations of those detectors, there is just not going to be enough for an astronomer to make this incredible conclusion that you're actually seeing something that came from a distant world.
And you've also argued for a long time that it's unrealistic to think that Earth is the only planet to host life, intelligent species. So based on all of your years of research and staring into the night skies, you're saying there is life on exoplanets. What are these exoplanets, and why do you think that's a given that there is life beyond that on Earth?
Well, I wouldn't say it's a given. I mean, I have arguments for why there could be probability on our side for it, but this is the lovely thing about science. Until you look, you don't know. And also, I can also give you arguments for why, in spite of the vast numbers of planets, that maybe there's maybe there's nobody around now, right? It could have been that life and intelligence was popping up all the time, but maybe in this era of the galaxy's history that we're alone. So I want to be careful about that. So I think it's important to say that, because so much of what science is not about belief, it's about evidence. So what is the evidence? I would say, as of right now, we don't have any direct evidence. What we have is a revolution that we went through about 30 years ago, and it's what's called the exoplanet revolution. We believe life requires planets on which to form. For 2,500 years, we have not known whether there were any other planets anywhere else in the universe other than the ones orbiting the sun. You can see Aristotle and Democritus beating each other up in their writings about this 2,500 years ago. Until as recently as the 1950s, there was convincing arguments that planets would be very, very, very rare, which would have meant life was even more rare. And then in 1995, we discovered our first exoplanet, a planet orbiting another star. And then since then, we now know, we've done this incredible work using these new detectors and technologies. We now know that every star in the sky hosts a family of worlds. And that, more than anything, is the game changer. We now know that the universe is awash in planets. Many of these planets, in fact, 1 out of every 5 planets is going to be in the right place for life to form, meaning that there could be liquid water on the surface. And what that means is that nature, we wrote a paper on this. Nature basically has run 10 billion trillion experiments in planets and life over the course of the universe, right? So in order for us to be the only time it's ever happened ever, the odds of it occurring on some random world have to be less than 1 in 10 billion trillion, which is so small that you begin to think like, okay, even if it's not next door, even if maybe our galaxy even is sterile, somewhere else in the history of the universe, there have been other forms of life and other civilizations.
It's amazing. I mean, in your book, you say, it's time to take the existence of aliens seriously. And that kind of gives you goosebumps, right? When you think about that, just that one sentence, like, okay, what does he mean by that?
Well, what it means, I mean, the most interesting thing for me is it means, I mean, of course we want to go out and we want to find the evidence, but even as an idea, it's a game changer because you just recognize that what has happened here, the long history of life on the earth and the miracles of evolution, the insanity of what evolution has produced, that likely has happened elsewhere, and who knows what paths it's taken.
Yeah, and I guess all of the what you call the giggle factor around UFOs, the bad sci-fi, the UFO conspiracy theorists, all of that, how much of that has gotten in the way of us asking the right questions, do you think?
Oh, it's huge. It's huge. I mean, so the field of SETI, Search for Extraterrestrial Intelligence, which was pioneered first, like the first experiment that was done with that was in 1959 by Frank Drake. During my entire life, that was always kind of like, people were like, it was always looked a little askance, even though you had some serious scientists doing it. And there was never really any funding for it, right? In fact, actually, a couple times NASA really tried to put funding behind the search for extraterrestrial intelligence. And then Congress in the 1980s and the 1990s just smacked it down. It became a political football, like, we're not going to waste money, looking for little green men. So that giggle factor actually has really impeded the real scientific search, which again, you're going to do with telescopes, not with jet fighters. That is really impeded. And it's only been recently, because of things like the exoplanet revolution, that finally this field is able to come out of the closet and and scientists will start taking it seriously. And we can talk a little bit more about sort of how that developed, but it is really just in the last couple of years. That grant that we got is an indication of the fact that finally this, people are willing to use the methods of astronomy to start looking for intelligent life.
So, how did that develop? Tell us a little bit about the background of how that change happened in attitude and that resulted in, of course, in funding.
Yeah, the most important, the 1990s were important for two reasons. First of all, within the solar system, you had this Mars rock that was found in Antarctica. It was a meteorite. It was a chunk of Mars that had been blown off of Mars and had landed in, Antarctica. And, a team, we knew this kind of thing would happen. And so a team found an example of this rock and they brought it back and it looked like, this was a phenomenal, it caused a great stir. It looked like there might have been evidence that this rock, that there were fossils in it. There were microscopic fossils of life in it, and as well as chemical tracers. Now, it turned out that, people now look at that and say, nah, that wasn't conclusive evidence, but it renewed the search for life within the solar system, the idea that there might have even been simple life on Mars. And that's what led to, Clinton, they amped up the study of Mars. They started all the rovers, the robots that we now, Mars is the only planet fully inhabited by robots, because we've sent a whole bunch there. That's where that started. And then alongside the same thing, same kind of spur was the exoplanet revolution I just described. And that began the search for life outside of the solar system. And it was, in the early 90s or mid 90s, we first discovered planets. By the mid 2000s, the first decade of this millennia, we had found so many planets that we could start doing statistics. We could start doing a census of them. And that led to a much deeper understanding of what might be possible for life. And that began the efforts in what we would call astrobiology, which is this new field that tries to look at life from a kind of planetary perspective or an astronomical perspective. And so people started thinking very seriously about what we would call biosignatures. If you have a planet that's 10 light years away and it's got a biosphere, it's got a rich, very thick network of life, on Earth, it's microbes and it's forests and it's, plankton in the ocean. That actually changes the atmosphere. That will leave a profound marker in the atmosphere. And those markers can be seen from a distance. When we look at the light that is reflecting off or passing through the atmosphere of a distant planet, we can actually see the fingerprint of that biosphere in the planet's atmosphere, and we call that a biosignature. So, for example, oxygen. What's amazing, people don't really realize this, but that if it wasn't for life, there would be no oxygen in Earth's atmosphere. about 2.5 billion years ago, microbes, blue-green algae or blue-green bacteria, basically, you pardon my language, it farted oxygen into the atmosphere due to this innovation in photosynthesis that it had evolved. And so without life, if life disappeared tomorrow, all the oxygen in the atmosphere would pretty much react away, and it would be gone. We'd go back to mostly nitrogen and some CO2. So oxygen, if you could see oxygen in the atmosphere of a distant planet, you'd have strong evidence that there was biology there. So these biosignatures, NASA pumped a huge amount of money into the study of these biosignatures. We've already characterized the atmospheres of some big, sort of Jupiter-sized planets that are, surrounding other stars. So we're already learning how to do this atmospheric characterization. And then what happened was, look, if you're going to be searching for, I don't mean to be derisive, but dumb life, right? If you're searching for microbes, and I'm not dissing microbes here.
Yeah.
But,
you're going to get a lot of people very upset about that.
No, listen, I'm a big fan. Microbes are smart. So I'm just, but what people realize is, look, if you have this maturing field of biosignature studies, how can you just sort of say that, like, okay, but we're never, ever, ever going to talk about intelligent life, right? Here's $50 million to study, biosignatures, but don't ever, ever bring up the idea of the possibility of technosignatures. So by somehow around 2018, it became clear that that doesn't make any sense. And then NASA hosted its first conference, a workshop on technosignatures that I was lucky enough to attend, where they kind of asked the astronomers, who most of these astronomers have been kind of living on the edge, having this be part of their funded work. Suddenly they gathered us all together and said, what would you guys need to do if we gave you money? And everyone's like, really?
So what are these technosignatures?
Yeah. So that's what we're working on now. We're trying to figure out what constitute the best signatures of a technological civilization. And there's all kinds of challenges in sort of figuring out, you want to try to avoid human biases, but on the other hand, you don't want to ignore the the one example you have is us. So you want to at least build on that. So let me give you a few examples of what we think might be good things to look at. The easiest one to look at would be pollution. And by pollution, I just mean, if there's any kind of industry that is, pumping out either purposely or inadvertently chemicals into the atmosphere that could not be produced by nature, then the question is, could you see those? And one of the things that came out of our collaboration, the grant, is we just submitted a paper that showed that chlorofluorocarbons, CFCs, which are the chemicals that actually mess with the ozone, that if another civilization 10 light years away was using CFCs and dumping them into their atmosphere at the same rate we would be able to see that with the telescope that's going to be launched next year. So, now you can say, well, would they use CFCs? I don't know, but this was an important first step in showing that an industrial chemical, a chemical that wouldn't show up any way other than technology, would in fact be detectable at Earth levels on a distant planet. So that was pretty cool.
Wow. And so you mentioned solar panels as another example.
Yes.
That kind of blew my mind. I'm like, wait, there's aliens installing solar panels? I couldn't quite get my arms around that one.
From Elon Musk. Yeah, he's way ahead of me. Well, now here's the interesting thing. So one of the difficulties when you think about technosignatures is you're like, okay, what are the possible routes of evolution for a civilization, right? That's, how do I constrain that? How do I even begin to think about that in a general but yet systematic way? Well, here's the thing. What is a civilization? On some level, it's just a mechanism for harvesting energy and using it to do work, right? Any civilization, that's what it would do. It has to take energy and use it to do something. So how do you harvest energy? Aliens aren't going to be magic, right? They're going to have the same sources we do, even if they're more efficient or have larger scale of collecting it. And the most obvious kind of energy is solar energy. The sun produces a titanic, an apocalyptic amount of energy every second. So, there's only a few kinds of ways you can build solar panels. So we have some idea about the components of that. And so, certainly this is something you can imagine us doing in the future. We might cover half the moon with solar panels and then beam that energy back down to Earth. So if you did that, the light that would reflect off of the solar panels actually would carry a signature, an imprint of the fact of the minerals that were being used or the materials that were being used. And you could see that at a great distance. So that's a lovely technosignature. Likewise, city lights or heat islands. At some point in the next maybe 20 or 30 years, we're going to have the capacity to resolve or begin to resolve planets. And we might be able to actually see on the night side, lights, or in the infrared, we could see the fact that there's industry going on there because there's going to be heat islands. So those are three. I mean, the list is growing and we have to evaluate each one of these, but those are three, examples that we've really talked about, and some of which we've already begin to study in some detail that we'd be able to see from a distance.
And through this NASA grant and all of your observations and computations, you're actually creating a Technosignature library. What is that going to look like? That's amazing.
Well, the idea is people are going to go, astronomers are going to go out and take observations, like with biosignatures. They're going to take the James Webb Space Telescope, which will be launched next year, and they're going to point it at a specific exoplanet. I mean, that's the beauty of the exoplanet revolution. Rather than just randomly looking in space for evidence of life, we now know exactly where to look. We're going to look on those planets that are in the right place for life to form around their star, what we call the habitable zone. So astronomers are going to be staring at those planets, for hours and hours and hours, collecting data, and then they're going to take that light and they're going to break it up using a spectra or a spectrograph, and then they're going to look for signatures of things like oxygen or methane. By creating this Technosignature library, we're going to also say, hey, look over in this wavelength band, look between, this wavelength and that wavelength, because that's where like the chlorofluorocarbon signature is going to be. And this is how strong it should be. So we're going to give observers kind of the library that they'll use, that when they take data, they are going to look and see like, oh, did we see chlorofluorocarbons? Did we see reflected light from from solar panels? And hopefully we'll build up a large enough library that every exoplanet observation that's looking for biosignatures can also look for technosignatures.
That's fascinating. And so what do you think these exocivilizations on these exoplanets might look like? Do we have any theories at all, or any sort of thoughts on this?
Well, this is and this is part of what has to happen now. That question is, one has to ask, if I want to answer that question, what guardrails do I have in thinking about that? Because I always like to say that science is constrained imagination, right? If I'm writing a science fiction story, I can just tell you anything about the aliens. But with science, I have these patterns, these rules that I've learned about that I know operate, everywhere in the universe. Now, I know that physics is always the same. Chemistry is always the same. I'm going to believe that Darwinian evolution is probably, because that just makes so much sense, that's probably the same. Now, when it comes to things like sociology, I don't really know that I can use sociology. I mean, are aliens going to be Marxists or capitalists? There's no way to tell, right? I just don't think there's anything that could constrain those. But what we can do is we can try, as the field matures, is try and systematically think about the ways that civilizations might evolve, right? How they might rise in their capacities, their technological capacities. So for example, what we're going through with the Anthropocene and climate change tells you that if you harvest too much energy and you're not careful about your impact, your planet is going to be like, sorry, the planet's going to push back. There's going to be back reactions. So one thing you might imagine, that if the civilization is really long-lived, not a couple of hundred years like our technological civilization has been around, but maybe like a million years, it's going to have to learn to come into some kind of balance with its biosphere, right? So that's like, there's an idea that may be general enough that, that may be we can use that as a guiding principle.
Yes, that was really interesting, because that was the first time I thought of it in those terms of how we have to, I've thought of it in other ways, but this idea that a lot of the crises on Earth, as you've mentioned, come because we are off balance with the universe, right? With the Earth, with our Earth. And so, going back to your reference to Anthropocene, you divide the evolution of our world into two phases: the Holocene and the Anthropocene. Could you describe what each is and why this is so relevant, particularly for climate change, and what it means for the balance in the universe and ultimately the future of humanity?
Right, right. Well, so, the interesting thing about the Earth, once you wake up to geology or, biogeophysics, as I did when I started working on this, 10 years ago, was you start seeing everywhere around you how this incredible 4 billion year history of life and the planet are just completely intermingled, right? The Earth and its life have been co-evolving since life began. Like, the example of the oxygen that I gave is a beautiful example. Once life pumped oxygen into the atmosphere, it changed everything about how the planet worked, as well as changing everything about how life would evolve. So there's all these different phases. The Earth has gone through many, many different phases where, different animals like dinosaurs were dominant. And in the last million years or so have been a period of ice ages. The ice has come on. You've had glaciers going all the way down to mid latitudes, and they've retreated. And what the last 10,000 years of Earth history has been what we call a interglacial. It's been a period where the glaciers retreated, and the climate has been relatively warm and relatively moist. Moist because all that water is not locked up in glaciers. So it just so happens that all of human history is fit into the Holocene. We didn't start doing agriculture until just after the glaciers retreated. So humanity or civilization, and by civilization, I mean everything that happened after the agrarian revolution. All of civilization is a story written in the Holocene during this one particular climate state that the Earth has been in, and it's been in many. And then what happened is we were so successful at energy harvesting, which is what we've been doing since the agrarian revolution. First we used animal dung, we used wood, and then we tripped over fossil fuels at some point. And we were so successful at harvesting that energy and building our civilization that we now have pushed the Earth out of the Holocene. We're pushing it into a new state that's called the Anthropocene, where the climate is going to be very different. We don't know what it's going to look like, because it's changing. But the danger is it's not going to look anything like what a complex civilization like ours needs or can thrive in. So this transition that we're making into the we're literally causing the Anthropocene is, it's unbelievably fascinating from an Earth science point of view, because now you have a technological civilization and it has pushed back on the world. And now the world is pushing back on the civilization. And it's important for understanding what's happening to us and our own fate. But of course, it's important for thinking about the fate of all civilizations, because what I believe is, and I think there's good arguments for, pretty much any civilization is going to hit this boundary. Some kind of every technological civilization will hit, or at least many will cause their own version of an Anthropocene.
Yeah, as you've mentioned, and we've sort of explored in a couple of other episodes we've done on UFOs, right? There's this inextricable link in the people talking about UFOs and other life to climate change, right? We've been talking in the US about climate change, going back 50 years, right? When, as you pointed out, Lyndon Johnson did a joint address before Congress. And yet we just really have not done enough to curtail ourselves. And you kind of compare us to cosmic teenagers. I love that idea. Where did that come from? And what do you mean by that?
Well, I think that the term was originally used by Carl Sagan in one of his, TV shows, Cosmos, from the 1970s. But it's such a beautiful idea, because it's, one of the things I think that's difficult when we talk about climate change is because it's become so politically polarized that people either deny it's happening, or they take it to say that like human beings are a plague, we're a virus on the planet, the Earth can't wait to get rid of us. And I think that is first of all, it's wrong. It's just the wrong perspective on how life and the Earth have evolved. But also, you're not going to get anywhere with that, right? That's not a narrative that's going to be helpful in trying to marshal our collective actions. But the teenager idea is really important because, anybody who's had a teenager, that moment they have to give the kids the keys to the car, whether you're religious or not, you suddenly learn how to pray. Because, adolescence, we know every human child is going to go through adolescence. It's a natural, phase of human development, and it's a dangerous transition. Not everybody makes it through. And I think that's the right way to think about technological civilizations. They are powerful enough to harvest energy in ways that life by itself wouldn't be able to do, non-technological life wouldn't be able to do. And in doing so, they cause feedbacks on their planet. And then the smart ones, the adolescents, the teenagers who learn how to manage this power they have over themselves, like in driving, are the ones that go on, and the ones who can't, they don't make it through the transition. So we should really think of the Anthropocene as a dangerous but expected transition. And I believe that might help us understand what's this profound moment that we're going through.
And this idea of the greenhouse effect, right? The runaway greenhouse effect, and how it could potentially destroy our life and humanity. There are some interesting comparisons you have to what is happening at Venus's core. I thought that was really amazing.
Yeah, we actually have two examples of climate change in our solar system. And that was what I was talking about in the book, was showing how, just again, because I've had to deal with so much climate denial in my life. I wanted to point out to people that, look, we don't know, our knowledge of climate change doesn't just come out of, studying the Earth. It's this long, long history of studying all the worlds in the solar system. And the first place we actually really came to understand how climate change can run amok was by Venus. It was one of the first planetary explorations we ever did. And so Venus is a world that really should look a lot like the Earth. I mean, it's the right, same size, same mass. It's a little bit closer to the sun, but that in itself won't make it that different. Instead, the temperature there is 700 degrees Fahrenheit. You can melt lead on the surface of Venus. And that's all because the greenhouse effect got into this very dangerous runaway, essentially, that caused it to just, it boiled off all the water that was on the planet. But Mars used to be, we think that Mars used to be a blue world. Mars had a period where there was absolutely water, maybe deep water, oceans perhaps, on Mars. But the climate changed, it lost its atmosphere, and now it's a frozen hellhole. So, both of those planets, now on Earth, climate change would never get that bad, but it could get bad enough that it makes civilization either impossible or very, very difficult. And so these two planets, these examples show us about how what it shows us is that planets have rules, right? Planets have rules for how they behave. And our civilization grew up not knowing those rules. And now we know them, and that means we have to rebuild our civilization to work within the biosphere or the planet's rules. And if we don't, then, it's not the planet that's going to lose, it's us that's going to lose.
Yeah, when I read the book, I had a renewed appreciation for our atmosphere and all of the gases that protect and keep our oxygen in, because I was looking at the alternative and it wasn't a very pretty sight. So, I want to pull back a little bit. You have this incredible mission, looking for extraterrestrial life and intelligence, in a galaxy far, far away. And what is that process like day after day? And, how close do you think you are to actually finding the kind of data that is going to revolutionize our understanding of extraterrestrial intelligence?
Yeah, it's interesting that you asked about the day-to-day, because as I like to always say, science is very exciting and it's unbelievably boring. Because, to know something incredible, right? To know about the structure of matter, to know about, what the code that allows life to work, to find evidence of extraterrestrial life of any kind, smart or dumb, requires this long, painstaking process of building up your theoretical understanding, of doing the experiments that build up your ability to make observations. And this process is essentially, why we have cell phones that work. It's how I can talk to you over a computer. And it takes a long time, and it requires a kind of obsessive personality that makes sure that you get the answers right. Right? Because if the people who were designing the science of your cell phone got it wrong, your cell phone would be a brick, right? So for technosignatures, and that's why I want people to understand, is we are just setting sail now. We did not have these capacities 30 years ago. We didn't know that there were exoplanets 30 years ago. It's only because of the work that's been done over the last 20, 30 years that we now are poised to actually be able to do this search. And so what does it mean? On one hand, on the theoretical side, we've got to think about what it is we're looking for. We have to be very clear and make models of, of how gases, different industrial gases would get into an atmosphere, how long they would be there, what kind of imprint they would leave on light. And then the people who design telescopes have to think about instruments. I have to design an instrument that can collect light from a distant star and, be very well characterized in terms of, how internal reflectance, happens, how much light gets absorbed and lost, all these kinds of things. But we have telescopes that are going to be launched soon. We have telescopes that are on the drawing boards now. And we have even the next generation of telescopes in place, such that in the next 10, 20, 30 years, we're going to actually have data about that's going to be relevant to this question. I can't tell you what the data is going to say, but we've been arguing about life in the universe since we've been humans. And we are now, for the first time, rather than yelling at each other about our opinions, we're going to actually have data. And this is, it's hard to imagine how profound that opportunity is. So we're just starting. And so, people have to be patient, and nothing good comes easily. But, I expect that in my lifetime, I will see data that's going to be relevant to this question.
That's absolutely amazing. And speaking of people yelling at each other, there's so much science denial going on these days. So you have that on the one hand, and then you have the kind of groundbreaking work that you're doing. How do you sort of reconcile the two and this incredible science denial that's going on? And what do you make of that?
Yeah, it's funny, during my time writing the NPR blog, when there were still comments, there was still a comment section. I really, watched this. I watched how, if I would post something about climate, when I started the blog, in the mid 2000s or late 2000s, you'd see a few people deniers like, well, you don't really know that's true. You're just it's pushing back. And then after a few years, I'd notice I'd put up a story and there would be an avalanche, almost as if there was a network waiting to be activated. That would then, people told me, I got death threats. People told me I should, I'm going to have to spend time in a 3x5 cell, which I said, well, that'd be great if I get my journal articles, I'd finally be able to read them. So what I make of it is that, I really believe to a large degree, it was orchestrated, right? I mean, when it comes to climate, there are obviously, actors who stand to lose. We know this now. It's been well documented. The oil companies and, other organizations associated with them they knew exactly what the science said, but they funded very sophisticated disinformation. And so what they did is they kind of hijacked the other cultural phenomena that were occurring, the things that led to the kind of polarization we see, so that this science got attached to that polarization, which was so cynical. Because as I wrote about this, once you start going down that slippery slope, once you start telling people that scientists are, it's a hoax, they're propagating it just for their own money, then you're not going to be able to pull out. There's no separating that argument about climate from something like, a pandemic. Once you've taught people that scientists are just in it for their money and that you can't really trust them, then when you get to things really going bad and you really need people to pay attention to the science, it's going to be too late. So it's a huge problem that cannot be underestimated, and it affects all parts of American society, because other cultures are not going through this. I mean, there's science denial everywhere, but the degree to which it is dominant in the United States, or not dominant, but that the strength of it in the United States does not bode well for our economic competitiveness, does not bode well for our ability to maintain our scientific supremacy, which we are. We definitely have the best scientific enterprise in the world, and that is absolutely threatened. I already can see ways in which we're going to start sliding. Because people aren't going to want to come here. The best and the brightest in the world aren't going to come here. So yeah, it's a real issue. And I even think that the UFOs could be helpful, because I advocate full, transparent exploration of this, and it's a great opportunity to show people how science works.
That's great. So your closing thoughts on how people should react to this government report, and what they should look for, and how they should process the information.
Yeah, that's a great kind of way of phrasing it. I think what people should do is, always read it critically, right? Read it critically. Remember, look at your cell phone and imagine all of the work it took to make that thing actually operate. The miracle that, the scientific miracle that thing is. And ask yourself, is the same kind of standards of evidence, or same kinds of scientific logic being used when people try and connect the what is unidentified with the idea of aliens. So everybody should look at it with interest. But if you're really interested in finding life on other planets, pay attention to what's happening in astronomy right now in the field of astrobiology, because that's really where you're going to get your answers.
That's wonderful. Adam, thank you so much for joining me on Techtopia and for this fascinating conversation.
Oh, it was so much fun. Thank you.
Adam Frank is a professor of physics and astronomy at the University of Rochester and a leading expert on the final stages of evolution for stars like the Sun. His computational research group at the University of Rochester has developed advanced supercomputer tools for studying how stars form and how they die. A self-described evangelist of science, Frank is also committed to showing others the beauty and power of science and exploring the proper context of science in culture. Among other things, he's a frequent commentator on NPR, and he's also the co-founder of NPR's blog 13.8 Cosmos and Culture. Last June, Frank won a NASA grant to fund his study of so-called Technosignatures, detectable signs of past or present technology used on other planets. This is the first NASA non-radio Technosignature grant ever awarded and represents a very exciting new direction for the search for extraterrestrial intelligence. And don't miss Adam's guest essay in May in the New York Times titled, "I'm a physicist who searches for aliens. UFOs Don't Impress Me." He's also the author of the book Light of the Stars, Alien Worlds, and the Fate of the Earth. It's a great read, and I'd highly recommend it. This is Techtopia. I'm Chitra Ragavan. Techtopia is a podcast from Good Story, an advisory firm helping technology startups with brand strategy, positioning, and narrative. Our producer is Jeremy Kaur, founder and CEO of Executive Podcasting Solutions, with production assistance from Kate Cruz. Our creative advisor is Adi Wineland, and our research and logistics lead is Sarah Muller. Don't forget to subscribe to the show on Apple Podcasts or your preferred podcast platform. And if you like the show, please rate it 5 stars, leave a review, and do recommend it to your friends, family, and colleagues. For questions, comments, and transcripts, please visit our website at goodstory.io or send us an email at podcast@goodstory.io. Join us next week for another episode of Techtopia. I'll see you then.